Okay, so we ran this model. We found out that there was a significant interaction effect, and now we need to probe this interaction effect. However, in the past, how have we probed interaction effects? What have we done? We've done what? We've done simple slopes, and how do we set these simple slopes? What do we do? Where did we do it at?
Plus point something.
Yeah, we had to use defined variables, right? We used defined variables to do this. However, I just said a moment ago that you can't put latent variables in the defined statement, so we have to come up with a new trick to do this, right? And the new trick is to use model constraints. And we can also use model constraints to calculate our indirect effects, because we couldn't get indirect effects before. So we're going to do it. We're going to start, before we do that, we're going to set this up so that we can calculate our indirect effects. So we have model constraint here. Model constraint allows you to specify new variables that are not included as part of your model fit or anything else. These are variables that you want to look at outside of your primary analysis. They can be variables, they can be paths that you've multiplied by paths, they can be all kinds of things. They do not affect your model one way or the other. They won't change model fit, they won't do anything of the sort. So what we're going to do is we're going to say model constraint, and we're going to say new. And we're going to name these new parameters. I guess calling them variables is not accurate, because these are all new parameters. And so we're going to name 4 new parameters here. We're going to go ind GSC, ind PSC. And this is the indirect effect from good self-control to alcohol problems. And that is multiplying 2 paths. It's multiplying the path from good self-control to alcohol use and multiplying the path from alcohol use to alcohol problems. If we scroll up to our model here, the path from good self-control to alcohol use is B4. And so we will put B4. And the path from alcohol use to alcohol problems is B1. So we will put B1. B4 times B1. Similarly, the path from alcohol use, or from poor self-control to alcohol use, is B5, right? So if we look at our model here, this is path B4, right? This is path B1. This is path B5. This is path B1. So we're going to multiply B5 times B1. We're going to multiply B4 times B1, and that will give us those indirect effects. Now, let's do something else before we go any further. Let's comment out our latent variable interaction, okay? And then let's also scroll up and let's comment out type equals random, algorithm equals integration. The only reason that I want to do this is I want to show you that when we comment back in model indirect, we will get the same values. Model indirect is the simple way of doing this right here. But we can't run model indirect if we have algorithm equals integration, so we've got to comment that out, and we've got to remove that latent variable interaction. So has everybody done this? This is the very first model that we specified, right? Okay, let's hit save, and let's hit run. Were you not ready? Who is not ready for that? We're all ready? Okay. I have an error here. New and plot parameters must appear at least one model constraint, GST. Did I mess that up? Oh, I'm sorry. We have 2 other ones. This is the total effect from good self-control to problems and the total effect from poor self-control to problems. And that is just this indirect effect plus the main effect, right? So our main effect, B3, is right here. We're going to add this. We're going to calculate this indirect effect, and then we're going to add that to it. That's our total effect, right? We're going to calculate this indirect effect, and we're going to add this path, which is B2, and that's our total effect. Are we all tracking there? Okay, here's our main effect, PSC, on problems. Here's our main effect of GSC. So in order to get the total effect, we add the main effect to the indirect effect. And in structural equation modeling, adding those two things together is called what? What rule? The tracing rule, right? The tracing rule says that, do you recall? For any indirect effect, we have this to this to this, even to this, right? The tracing rule says that for any indirect effect, you multiply this times this times this, right? We're not doing this last one. We're just doing this times this. That's the tracing rule, right? That's the first part of the tracing rule. The other part of the tracing rule is to get a total effect, you can just add this one. So you're multiplying these, you add any other paths that aren't in that indirect effect to get your total effect, right? And they call it the tracing rule because you're tracing through your model. So we have the indirect effect plus the direct effect for each one of our primary predictors, good self-control and poor self-control. Are we all good now? Can we hit run? Okay, we hit run. Our model fit should be exactly what it was before, which was what? 124 degrees of freedom, 333. That's what we have, 333, 124. Model fit, it looks exactly the way it did before. What we are going to get now is additional / new parameters. So you can see from good self-control, we have minus 0.352 for an indirect effect and minus 0.503 for a direct effect. And for poor self-control, we have 0.127 for an indirect effect and 0.419 for a total effect. So remember those numbers, 352, 127, 503, 419. Kelly, we got an error?
I got an error.
What's the error say?
It says unknown variable in an on statement, GSC, ALC.
Yeah, we got to comment that out. Remember, we're commenting out I said we're going to comment out the interaction.
Okay. Can we see it?
Yep.
Yeah, let's look at these.
We're still trying to do this.
So we removed this, right? Commented that out.
That's the one I failed to comment out.
Commented this out. How far? This far?
I still have an error, it's just now a different one.
What's it say?
Only one sign is allowed for each statement, problem component statement starting with IND GSC.
Okay. What do your statements say? Do you have IND GSC and IND PSC?
Yeah.
I'll come look.
Here we go. Semicolons.
Oh, Colleen, how about you? How are we coming?
Success. We got the numbers.
page. Look good. All right. So does everybody have the same model that I've got up over here? Yeah? Okay, so, oh, my model is not up. Hold on. This is the original model that we started with, the structural model, and we are now calculating or computing our own direct and indirect effects rather than relying on M+ to do it. So I am going to stop right here. Somebody scroll down to model indirect and tell me what it says for good self-control for the indirect effect and the total effect. Do they match these new parameters that we created? Nobody knows? Who has model indirect in their thing?
Can't find it.
You guys didn't comment it back in? Okay, so then just stick right here. Stay at the new additional parameters. I did comment it back in, so I'm going to scroll down here and look at my model indirect effects. So do these two values match what we calculated? The new parameters? And do these two values match the new parameters? They should all be exactly the same. We're just doing it ourselves now rather than having M+ do it for us, right? We created those parameters ourselves. And I just wanted to run this to show that this is what M+ is doing. It's just multiplying these things out. And you don't need to ever use model indirect effect if you don't want to. And as your models get more complex, you won't be able to use model indirect effect or model indirect anyway. So it only works with the most basic types of structural equation and path analysis models. All right. So
did you change the random to something else? Because when I'm using indirect plus this thing, it says that it cannot be used with the type of random.
I just commented out random.
Oh.
I commented out random and I commented out integration. All right, let's add these back in. And let's comment this stuff back out. And then let's run this just to make sure that our model is working. Oh yeah, that's right. We have to add in type equals random, algorithm equals integration. There we go. Now it's thinking. Is everybody else's as slow as mine?
I've got results.
You do? There we go. Scroll down here. Terminated normally. And we have a significant interaction effect right here. So all is good, right? Where are our, there's our new parameters. These new parameters are not standardized parameters, they're unstandardized, right? You can get standardized parameters. But these are unstandardized, yeah.
So if mine don't match yours, is that a bad thing?
It is a bad thing.
Okay.
What does yours say?
I just have negative 0.249 for the first one.
Okay. Then you guys did something else. Close this up.
Scroll down to where you made these new. So you put these in a weird spot. They are supposed to be up here. So you're multiplying times these list statements.
So go back and fix that.
Yes, we did something. So it was the tote one that is not up with yours.
The B1, B2, B4, B5 is the on statements, not with statements.
Tote GSC.
So you bring in here,
Plus.
Yeah.
because then you're
I really need to sign this change.
you're telling yourself with statements. So this is not right. It didn't matter until now.
Okay, so we were 361 correct, 540 is correct.
Yeah.
With PSC, so Thomas goes out. So PSC, because it's always the alcohol. You always want the alcohol. And that you want alcohol. If you're multiplying this PSC to alcohol, and then alcohol to problem. Right? And then down here.
I rise. I do it. Stop it. This is so that's
Okay, are we all good now?
that's
If you learn nothing else from this class, it's that M+ code can be, it's easy to make a mistake with M+ code, right? So this is why it's important to sometimes check your code against like model constraint or something like, or I mean against model indirect. If you can, you will get to a spot where you can't. Like right now, we can't run model indirect, right? Okay, so we've run this, we've double checked our indirect effects, all of that looks good. We now have a significant interaction effect. And now the question is, how do we probe that interaction effect when we can't use the define statement, right? Well, the way that we do this is twofold. First, I said that latent variables have a mean of 0 and a standard deviation of 1, right? But that's only when they are standardized. And in order to get a standardized latent variable for the, because remember I said all of these new parameters that we're creating are unstandardized. So in order to get those in the standardized form, we have to create latent variables that are standardized from the get-go, right? In order to do that, we want to set our latent variable variance to 1. And so instead of setting the scale, we're going to set this to a z-score, right? Now, before when we've made latent variables, we've done something like this. We've fixed this to 1, right? Now, we're going to fix this to 1, and we're going to leave this. That sets our scale to z rather than to the scale of this variable, right? So let's do that. Let's set our scale to z by saying GSC at 1 and PSC at 1 and ALK at 1. And we're not going to change the scale of problems. Totally cool with it just being the way that it is. You can change the scale, it doesn't matter, it doesn't affect it one way or the other. But if you change the scale of problems, then the intercept becomes 0, right? And we actually want to know what the intercept is for problems because that's our mean level of problems. And so I like having that scale there. But we can change the scales for all these other ones because we're not concerned with the intercept. We don't care what that is. We're concerned with the intercept if our outcome is it. So we set all of these. There's actually one other thing that we have to do for this to work correctly, but I don't want to do it yet. I just want to run this the way that it is. You get an error if you do this? You shouldn't. It should run. But we set that variance to 1, which means that this path should no longer be 1, right? Did you get an error? Did anybody get an error? No? Okay. So we scroll down here. Everything terminated normally. This is still 1. And it shouldn't be setting it to 1 because we're already fixing it to 1, right? Now we're burning up 2 degrees of freedom per latent variable. Anybody want to take a guess? How can we get that to not be 1? It's probably unfair for me to ask you to guess when I've never showed you this. This is what we do. The variance is already set to 1. We just go in here and tell m plus, hey, let's just make this freely estimated. This is the sign to m plus to freely estimate that variable, that thing. Put a little asterisk there. And hit save. Everybody good? Hit run. Put an asterisk for the first indicator on those 3 latent variables. That's all it is, Kelly.
Got it now.
Okay, we hit run. By the way, if you actually compared the BIC here, this is 26963. The other model is 26964. So it's just a little bit lower, right? I think that you can be justified by saying like, hey, the previous model showed good fit. It was re-estimated. The BIC decreased by 1 value, but we did have a significant interaction effect, right? So it's probably not an improvement over the model, but it does allow you to look at that interaction effect. All right. Our interaction is still statistically significant. And our latent variables now, these are no longer 1s, right? They're all there the way that they're supposed to be. Our variance of our latent variables are 1. So now that our variance is fixed to 1, our standard deviation is also 1, right? Everybody have what I have here? All right. Let's go in and probe this slope. We're not going to actually do it within the context of the model. That's what we've always done in the past. But now we are going to probe that slope all in model constraint. So we have done this in model constraint. We've already checked all of these. We know that those indirect effects are accurate. We're going to add this statement here. We're going to say new low good self-control, high good self-control, low good self-control alcohol, high good self-control alcohol. These are all new variables that we're going to create. And in order to do this, we're going to say that low good self-control equals -1. And all this is doing is allowing us to do what we did before in the define statement. We don't need to do medium good self-control equals 0 because this is a latent variable and it already has a mean of 0 and a standard deviation of 1. Then we're going to do high good self-control equals 1. And this will set it to +1 standard deviation above the mean of good self-control. Notice that this is different than what we did before. Before we were subtracting 1 in order to get high and adding 1 in order to get low. M+ knows that you don't actually have to do this. It sets it so that if you say -1, it's going to be low. If you say +1, it's going to be high. And then we will do low good self-control alcohol, high good self-control alcohol. And that is just saying B1. B1 is our relationship between alcohol and problems, plus B6, which is our interaction, times low good self-control, and our interaction times high good self-control. We don't need to do times mean self-control because that's what this effect is already, right? It's when good self-control is held constant at 0 and when alcohol is held constant at 0. So this is going to tell us what those simple slopes are at high and low levels. Are we all ready?
I have a question.
Yeah.
So you're saying that M plus understands we don't have to invert the high and low minus and plus, right? Why do we have the omitted part that sort of tells M plus, or it looks like it's telling M plus?
This part here,
Yeah, is it?
that's just for you guys.
Oh, all right.
I just typed that in there for you guys, yeah. All right. I'm going to hit save and I'm going to hit run. Everybody should be caught up at this point, right? Our model fit should not change. None of the effects within our model should change. Everything there should be exactly the same. We just now have this added interaction, or these added slopes. So scroll down. Whoops, I scrolled right. No, I didn't. This is doing nothing but just setting these values, right? Now, we have these two new values right here. Low good self-control, high good self-control, right? What do these refer to? What are those the slopes of?
There's a low value of at a plus 1 standard deviation of the self-control of the moderator.
Okay, so it's the relationship between what and what at what?
The relationship between alcohol use and alcohol problems at high and low self-control.
Perfect. So let's first look at the relationship between alcohol use and alcohol problems up here. The relationship between alcohol use and alcohol problems is 0.675. If good self-control serves as a protective factor, that means at high good self-control, this relationship should be what? It should be less, right? And in fact, it should be less by roughly this amount. So if we scroll down here, at high good self-control, is it less? Yep. And if we come back up here, at high good self-control, at low good self-control, it should be what? Yeah, and it should be higher. Well, I mean, you can look at these and you can tell exactly what the value should be. What should it be?
675 plus 140.
Yeah, 675 plus 143, which is what? Is that 0.818? Is that right? 818? So that means when this is low, this should be 818. You can only do that just FYI, because it's all standardized right now, right? So we come down here. Oh, there it is. Look at there, 818. Perfect. So at high good self-control, the relationship between alcohol and problems is attenuated. It's less. At low good self-control, the relationship is potentiated or stronger, right? If you don't have a break, then the relationship between alcohol and problems is worse. If you have a really strong break, then the relationship between alcohol and problems is less. Does that make sense? We have one more step to this, don't we? We've adjusted this path. We've adjusted this path right here so that it can be higher or lower based on levels of this, right? What does that mean? Yeah, we have moderation and we have conditional indirect effects, right? Now, I said earlier we cannot look at conditional indirect effects of this, but we can look at conditional indirect effects of this. Will this path change? No, this path won't change at all, right? Will the indirect effect from here to here to here change? Yes, and it will change because this slope has different values based on what this is, right? This slope was 0.67, but it can be 0.53 or 0.81 depending on what this is at. And that means if you multiply this slope times this slope, you have the possibility of having various indirect effects. Make sense? Who's lost? Oh, that feels good when no one's lost. Actually, what it really means is whoever's lost is just like, I ain't seeing shit. All right, so let's come back here and let's finish up our last step. We're going to calculate the indirect effects of high good self-control on problems, the indirect effects of low good self-control, to problems for PSC, and then the total effect of good self-control to problems via PSC and the total effect here. All right, so let's have a look at these. We've already calculated these values right here, right? So this is the relationship between alcohol and problems at good self-control. We're going to multiply it times B5. What is B5? B5 is the relationship between poor self-control and alcohol use. Remember, I said we have to look at this indirect effect, poor self-control to alcohol use to problems, when good self-control is high and when good self-control is low. So we're multiplying that by B5. We're also going to multiply B5 times that slope when good self-control is low. So this is when good self-control is high, this is when good self-control is low, times the relationship between poor self-control and alcohol use in both cases, right? If we do that, that will give us our indirect effects from poor self-control to alcohol problems at high levels of good self-control and low levels of good self-control. But that's omitting the fact that there is also a total effect, right? In other words, even when good self-control is high, there's a relationship between poor self-control and problems that is direct, right? And we need to add that to that effect. And when good self-control is low, there's also still that relationship and it doesn't change. So we're adding B2, and if we come up here, B2 is the direct relationship between poor self-control and problems. Our basic tracing rule. Are we all good? Some of us are. Who's not ready yet? Who's not ready for me to hit run? Okay. Let me know when you are. We're all ready? Who's not ready yet? We're good? All right, let's hit run. We've already looked at that path, that alcohol path, and we confirmed that that path changes as a function of good self-control and poor control, or I mean high and low levels of good self-control. So we're not going to spend too much time looking at that again. Let's just come right here to our effects. So this is the path that we just looked at, right? And now we can look at the indirect effect between poor self-control and alcohol use, or alcohol problems. Yeah,
Can I see your input? I got an error.
you got an error? What's your error say?
It says a parameter label or the constant zero must appear on the left-hand side of the model constraint statement.
You misspelled something. And you should also, yours is also a typo. I don't know where you put it. So all of these variables, or these parameters, have to exactly match these parameters. Okay, let's run that again. We're going to start by comparing the indirect effect between poor self-control and alcohol use or alcohol problems when everything is held constant at its mean. So when everything is held constant at its mean, the indirect effect for poor self-control is 0.096. When good self-control is high, we know that that indirect effect should be less than 0.096, right? Here is high good self-control for poor self-control, and it is 0.076. That is less, right? When good self-control is low, that effect should be larger. We have 0.117. It is larger than 0.096. So we can say that this is a stronger indirect effect. Interestingly, our p-value here is 0.022 at an indirect effect of 0.096. Here we have 0.117, and our p-value is also 0.022. Why is that?
Because it does not change the peak. It's not change the significance. It just changes the effect size.
Yeah, the effect size is also a function, or the p-value is a function of effect size and what? Variability, right? Like the variance of that, or the standard error. And so, as you move things up, as you move up towards the standard deviation, if things are normally like, if your data is like this, and you're going right through here, you've got nice variance, right? But if you were to set it up here, then all of your variance is further away from that line. You wind up getting more standard error, right? And so if you look here, your standard error is 0.042 when everything is held constant at its mean. Down here, 0.051. The standard error is not the same. It's a little bit tighter, actually, right here. That's just a function of skewed data. It is skewed data. So, okay. Regardless, the effect size is this. The p-value is, I mean, if you ask me, irrelevant. Anyway, we can say that the effect is a little bit stronger.
But
Yeah.
you understand, like if the standard error is changing, then the p-value should change because it's effect size divided by standard error or something like that.
Yes, the p-value will change, but
It's not changing here.
oh, I mean, it technically is. It's just that it's changing by the same ratio, right? So if this standard error stayed at 0.042, then it would be 0.117 divided by 0.042, and that's how you would get a p-value that should be, or I mean a z-test that should be a little bit higher and a p-value that should be a little bit lower. But because this increase, it's just the fact that they both are 0.022 is just kind of an anomaly here. They shouldn't be exactly the same, but they are exactly, they just happen to be here. Usually, actually, this decreases. And in fact, we could go and we could set the standard we could probe this at +2, right, instead of +1, and then it would probably decrease dramatically. So, but anyway, so we see that, yeah, Kelly, go ahead.
I still cannot get this to run.
All right, hold on.
Throwing an error.
Does anybody else have an error? Is it running for everybody else?
I'm sure I'm doing something very stupid. If we could check this private letters.
Thank you.
There we go.
Just needed another set of eyes.
All right.
The stars means here, like there are stars for low and high.
Oh, because we just fixed those values as 1 and -1, right? There is no standard error. There's nothing to it. It's just fixed. Yeah. And we only did that so that we could then use those in our equations later on. So then we have a total effect of poor self-control of 0.318. That is the indirect effect plus the total effect, right? And if we look down here at high good self-control, it is way less at 0.298. Okay, not way less, but it's less, right? And it is more when good self-control is low. So you can see that good self-control is serving as a protective factor, reducing A, the relationship between alcohol use and problems, and B, diminishing the indirect effect and total effects of poor self-control predicting problems because of the changing relationship between alcohol use and problems. Does that make sense? Who is lost right now? Oh, that's a beautiful thing.
Have different numbers.
You should not have different numbers. Let's have a look. All right. That looks right. I'm going to guess that we need to do something like, yeah, put an asterisk right here. And once you put those asterisks there, then it will change.
And you do that for only
The first 3 latent variables. Don't do it for problems. You could technically do it for problems, but then problems becomes a z-score. And I always like to use the actual outcome, like a scale of the outcome, because if you want to look at an intercept, like the mean level of problems that somebody has, if you set that as a z-score, then it's going to be relative to 0. But if you use the scale, then it could be like, well, the mean level of problems in this thing was like 5.7 or something. It has some real meaning versus z, which has no real meaning, at least when it comes to outcomes. Yeah?
I also have different values for the parameters. Close.
No cigar. Take those out here. Scroll up. Are we all good then? What's that? You're having the same issue?
So it's not 1 anymore, it's
This Oh, it is, or is it times B5? It must be times B5. I'm sorry. It's times B5. Wait, what is your B5? Is it PSC on ALK? Hmm. Can you bring your computer over here so I can kind of look at it next to mine? All right, so four times B1, B5 times B1, B4 is good self-control on now. Were all of your numbers right before or no?
No, I've been trying to figure out what's been wrong.
Oh, you've been working on it.
Yeah.
Oh my god.
Endurance. Pop on L, pop on PSC, pop on GSC, L on GSC, L on PSC, pop on GCL. All looks right. Oh, yeah, you have int GSC equals this, int GSC equals this. They can't both be int GSC.
Told you. Just one little thing. Okay, thank you.
Yep. Okay. So now we have, let's walk through what we've done today. We specified a measurement model. We went through our modification indices to get a good measurement model, freeing errors that made sense or that had a modification indice greater than 20, which is just some arbitrary threshold that I like to use. We got to a set measurement model, then we specified our structural model. When I would write this up as a result section, I would have my descriptive statistics section, then I would have measurement model, and I would write up the measurement model. And I would say, like, we specified the measurement model by specifying the 4 latent variables to be used in the analysis. The latent variables were all correlated. They were correlated. You don't have to type all this out because I'm recording and you can listen to it later. All of the latent variables were correlated, and then I examined correlated errors within latent variable indicators. I iteratively freed correlated errors with the modification indice greater than 20 if they made good theoretical sense. And in this case, all 5 made good theoretical sense. I had 5 correlated errors. Then I examined the initial measurement model against the measurement model with 5 correlated errors using a Satora-Bentler chi-squared test. This Satora-Bentler chi-squared test suggested that the measurement model with correlated errors fit the data significantly better than the measurement model without the correlated errors. Thus, this was the measurement model that was retained for the structural analysis. Next paragraph, I would put it the subheading structural model. And I would say something to the effect of alcohol problems was set as the criterion variable or the outcome variable. Alcohol use was the mediator variable. And good self-control and poor self-control were the exogenous latent variables, right? This model was, and then say this model showed reasonable fit to the data and list my fit statistics. Next, we added a latent variable interaction between good self-control and alcohol use, because this was one of our hypotheses or some other reason that you would add that, right? I would specify up front, latent variable interactions require numerical integration, and thus we do not have traditional models or traditional indices of model fit. However, we saw a reduction in BIC, and there was a significant effect of the interaction on alcohol problems, right? Next, probably new paragraph, we probed the significant effect or significant interaction effect at high and low levels of good self-control. At high levels of good self-control, the relationship between alcohol and problems was attenuated. At low levels of good self-control, the relationship between alcohol use and alcohol problems was potentiated, or more robust, or whatever wording you want to use, right? This also resulted in conditional indirect effects from poor self-control to alcohol problems. At high levels of good self-control, the relationship between poor self-control, the indirect relationship and total effect between poor self-control and alcohol problems was attenuated. At low levels of good self-control, the indirect and total effect of poor self-control on alcohol problems was potentiated or stronger. Right? And there was a significant indirect effect between good self-control and alcohol problems that was statistically significant. And this is, you don't have to worry about conditional indirect effects when you're talking about this one, right? And this relationship was fully mediated as there was no relationship, no significant direct relationship between good self-control and alcohol problems. That is everything that we did today. Does that make sense? The way that I would put this into a paper is I would put the basic structural model to latent this right here. It would look just like that in the paper with the path coefficients listed. Then I would put a simple slopes model that just looks at this path, the relationship between alcohol use and problems at high and low levels of good self-control. And you can plot that using the Excel sheet that we've used dozens of times before, right? It's easy enough. You can just use the basic, the initial model of plug in the effect of alcohol use on alcohol problems in your original model, the interaction of alcohol use and alcohol problem, good self-control on alcohol problems from your original model, and the interaction of good self-control by alcohol use on alcohol problems in your original model, then the intercept, and then in the Excel file, you'll just tick 1 and -1 for high and low levels of good self-control, and it will plot it out for you, so you don't have to worry about that. You can plug that in. You've got your slopes that you've calculated already, and you can list those slopes either in the text or throw them on your figure if you want to be fancy about it. The last piece of this is that you will have to calculate or show a table that has the indirect effects. So the indirect effects don't vary for good self-control. I would just say, like, I would put a table that's broken up by good self-control and poor self-control. And for poor self-control, I might label it as poor self-control to problems at high good self-control, poor self-control to problems at mean good self-control, and poor self-control to problems at low good self-control. Does that make sense? And then list all of those values. What questions do we have?
You mentioned that we did Sator-Butler comparison. Where in the input did we do that?
We didn't. Who remembers how we got that last time? We had to do this last time.
We used that website.
Yes. Yep.
That compared.
Yeah, so the way that you would do it is you would just go to that website. So you would grab your chi-square value and your degrees of freedom from the very first model that you ran, and the chi-square value and the degrees of freedom, and your correction factor from the very last model that you ran, and then just plug those into that website and hit go, and it'll give you your chi-squared, Sator-Butler chi-squared. And then you can just say that the difference between these two was statistically significant. M+ won't actually test those. M+ will do a chi-square difference test, but not the Sator-Butler chi-square difference test. So yeah, unfortunately, in order to do that, you've got to go to that website. Several of you actually did that in your homework, went to the website and did the Satora Bentler chi-square. I appreciate that. It's nice. All right, any other questions? Well, then that is it. We are done a little bit early today. I will get these videos uploaded. Your homework is already there and ready for you to roll, and you are going to do the exact same thing that we did today. So follow with the videos, and put the homework actually says to put in the figures. So put in both of your figures. Put in your conditional indirects table. Have fun. All right.